This is the first in a series of video keys for the group study guide. This is question 1. For each of the following graphs of the polynomial functions, assume that the leading coefficient is 1. Also assume that all the x-intercepts are integers. 3 parts: give the number of turns in the graph, give the degree of the polynomial, and write a complete factorization. So let's just start with turns. We have a turn here and a turn here. So there are 2 turns. If you have 2 turns, you have at least a degree 3 polynomial, and degree is based on what the power of the leading coefficient on x is. This would be the 3rd degree. We have, if it's 3rd degree, that means we should have 3 zeros, or 3 zeros. Now we have 3 x-intercepts, so that matches up with this. Okay, so this first intercept here is -1, 2, 3, 4, -4, 0. This intercept here is -1, 0. And so this intercept is 3, positive 3, 0. Therefore, the complete factorization, if we label it as f of x, would be if we have an intercept at -4, 0, that means the 0 is -4, and the factor is x plus 4. We're subtracting this value. So minus 4 is plus 4. The next intercept we have is -1, 0, so this would be x plus 1. And the last intercept is 3, 0, so x minus 3. Oops. X minus 3. That's our complete factorization. So let's go to our next value. Here we have a 1 turn, so there's 1 turn here. 1 turn. You can see 2 intercepts. If it's 1 turn, it's at least degree 2. And if it's degree 2, we should find 2 zeros or 2 factors for our complete factorization. Let's call this g of x. And the intercepts here, an intercept is at 2, 0. And there's an intercept at 0, 0. So this intercept, when the graph goes through 0, 0, and intercepts the x-axis at 0, that just means we could say x minus 0, or simpler to just say x. And we have an intercept at 2, so x minus 2. And that's that solution right there. That's the complete factorization. Now, this next one, we see 1 turn here, 1 turn here, 1 turn here. There are 3 turns. We should be looking for at least then a 4th degree polynomial. It could be higher, but usually you'll see more every turn. If it's 4th degree, we're looking for 4 zeros. We see here an intercept at -1, 2, 3, 4, -4, 0. We see an intercept here at -2, 0. We see an intercept at 0, 0. And here at 1, 2, 3, 4, 5, 0. So this complete factorization, I'm going to give myself a little more room and write it here. H of x, we'll just use a different name for the function. H of x is equal to, now this 0, 0 again, we can just call that x. This one over here, x plus 4. X plus 2 for that intercept, and x minus 5. So here's our answer for this one. Now, turning to the last problem here, we see 1, 2, 3, 4 turns. 4 turns. And its degree then needs to be at least 5. So we need to find 5 zeros. Now, this one's interesting because we do have an intercept here at, let's see, negative 1, 2, 3, so negative 3, 0. Then we have an intercept here at negative 1, 0. And we have an intercept here at 1, 0. Now these two intercepts they just touch, they're tangent to the x-axis. That's a special case. Just to know that indicates at least a double root. It's actually an even root. It could be higher, of 4th degree, but generally speaking, it's going to be double roots. So the zeros in this, we have 5 zeros. We have a negative 3 if I were listing zeros, and then we have a negative 1, but that's double. So we have another negative 1, and we have a couple at 1. So when I write the complete factorization, let's call this one P of x. Give it a new name. We do have the factor, and this line goes right across the x-axis, so it has a multiplicity of 1. There's only 1 0 here, x plus 3. And then we have a factor at x plus 1, corresponding to this minus 1, 0 intercept, but that's double, so that's squared. Run out of room here a little bit. And then x minus 1, and for that, again, squared. So there's our answer for that one.